I'm the director of what we call the EWB, Engineers Institute. So I'm involved in kind of all of our programs that have to do with training, with education, and with research. And we've got a bit of a stellar lineup for you today. We're going to have a look at the different aspects that are involved in humanitarian engineering education. So what is it like to be a student that does these programs? What's the academic perspective about how this can be included in courses, in degrees? What's the role of engineering education internationally? As well as what's the contribution that innovation and research has to play in the broader sector that is humanitarian engineering. Now, you guys are all super smart, so these guys will provide a bit of kind of exposure to the work they've done and tell you some of the stories from the work they've been involved with. But the really meaty and quite exciting and sexy part of the session is a bit more of the interactive discussion. So I'm going to be incredibly hard taskmaster on the four speakers that we've got up, keeping them on time, so we've got plenty of time to have a really good quality discussion after they're spoken. So it's my absolute pleasure to introduce Tim Fraser as the first speaker. Now Tim's been involved in Engineers Without Borders research programs and has kind of been involved in the organisation in our head office, so seeing how the whole organisation runs. As well as his own project right here at RMIT. So please, let's get a really awesome energy going and give Tim massive amounts of love to...
Thanks, Julian. So I've been working on the design of an affordable recumbent Handcycle this year as part of my final year project. I'm studying mechanical engineering at RMIT. Just for those of you who don't know, a quick introduction to Handcycles. They've been around for hundreds of years, generally as an alternative form of transport for people who are wheelchair dependent. They can be sort of like an independent bike, or you can use an attachment to a wheelchair. They've been growing a lot in popularity in the last 30 years, and they're included for the first time in the 2004 Athens Paralympics. They're also of great benefit to people with wheelchairs. They're a bit more practical because you can go a lot faster, so you can do things like commuting and cover a bit more distance. And they're good cross-training for wheelchairs. There's been a lot of research that's shown that they're more efficient on the shoulder arm muscles particularly. If you haven't seen one before, that's a picture of me riding one that we borrowed from Melbourne Disability Sports and Recreation. So they're quite low down. It's a recumbent design, and the handles are synchronous, which means they go together sort of like this, just in front of you. They're quite awkward to ride. The turning circles are really bad, but that's something I'm trying to work on as well. But the main problem I'm working on is the cost is a massive barrier to accessing the technology. The cheapest one I found is this Intrepid Tourer, which is, when you add in shipping and conversion from US dollars, it's approaching $2,500, which is a lot of money for something that's effectively just rearrangement of a standard push bike. Something like this Recycle bike is only $250, and it's basically the same sort of thing as steel frame with gears and brakes and what have you. So I'm going to aim to develop a Handcycle that costs $1,000 or less without sacrificing any of the features that Handcycle users love. And I'm going to try to achieve that through the use of commodity parts and a simple chassis design. So I started with a research phase, which included a literature review. I found there's a lot of research on physiology, like which part is most efficient and angles and that sort of thing. I did some hands-on testing, and as you saw in the previous picture, and research of current models, as well as connecting with some Handcycle users to determine the customer requirements. Then I've started the design phase with the first prototype, looking at ease of use primarily through transferring, which is getting into the Handcycle from your wheelchair, and adjustability as well, so it can suit sort of big people, small people, and everything in between. And as well, trying to keep the weight as low as possible to make it easier to ride and make it fit in an average car as well. The basis of this, the first prototype, is used as a basis for optimization of chassis design and component configuration, as well as the design of a seat raising and lowering mechanism. So this is just to show you the issue of transfers. It's a big problem. You can see the height difference between this is a very low recumbent bike because it's a racing one, but you can see the height difference between the wheelchair seat and the seat of the cycle, and it can be very difficult to get in. In this case, this guy would pretty much have to get onto the ground and then get back up into the chair. So it's very awkward. That's why I'm trying to make some sort of mechanism that will raise the Handcycle seat to like a similar height, so you can just sort of slip in easily. And then I'm going to work on the second prototype, which will basically be an optimized chassis and component design based on computer simulations I've done, some literature review findings, user input and outcomes from the first prototype. And I'm also going to try and incorporate some better components instead of just scrap parts, custom components that I'll manufacture with RMIT's manufacturing facilities, and some other small parts as well. And then I'm going to do some work on costing, basically comparing a workshop model, which will look at buying, say, 2 or 3 scrap bikes and getting them cut up and welded back together in the frame I've designed, as well as getting parts, and comparing that to a mass manufacture model, which will look at sort of producing them in the low thousands, perhaps, from scratch using imported materials or materials from Australia. This is a shot of the first prototype before it was welded together. I just got a few scrap bikes from Sarah's bike shed for free and cut them up at home in my shed, and I got RMIT to weld them together for me. So it was 100% free and 100% made from, I think, 3 old bikes. So it's really heavy, but it's basically going to use it to learn more about it and hopefully make a better one for the second prototype. That's a CAD model ledger of the same thing. That's probably a bit clearer. I've got a separating part in the middle there so you can change the length, and you can also split it in half if you want to fit it in the car pretty easily. I also did some finite element analysis simulations, just looking at how the chassis bends when the forces are applied, when the person's sitting on it. So I'm going to try to do some more of them and look at adjusting various angles and things and playing around with it to optimize the chassis design. So far I'm trying to reduce the weight because it's really heavy, way too heavy, and it's pretty dangerous probably if you're going really fast. It's really difficult to stop. The budget as well, I've only got $300 from RMIT, which is not much, and it's very difficult to get any work done without any money. And the scope as well, it's difficult to, I should have defined it more clearly at the start, what I'm aiming to do, but that's sort of fixed now. And I'm hoping to continue working on it next year once the project's finished. I'm looking at options now, hoping it can maybe be continued as a final year project for students next year, with some input from me as well, or perhaps some sort of side project for interns at EWB or Enable Development. Hopefully it can continue because it could have a real world impact if it's sort of brought to market. And yes, I'm hoping to complete the first prototype very soon. Second one, sort of mid-semester 2, costing a couple of weeks after that, and then I've got my thesis and final presentation at the end of the semester. That's all.
What a really cool project, and what a really neat way to show kind of how research can be used to tackle a pretty significant and real problem. And yeah, what a neat outcome, the idea of bringing to market potentially a new product that's a full 50% cheaper than the cheapest thing that's out there made here in Australia to meet what is a really significant need. So well done, Tim. Start thinking about some of the questions you might be able to ask him when we move to the Q&A portion of the program. But I would love to now welcome Phil up. Now, Phil's been involved with Engineers Without Borders for a couple of years now, and probably most significantly with his work in engineering education, actually in country in Cambodia, where he worked with the Royal University of Phnom Penh, and has been involved and continues to be in academia here in Australia. So a really beautiful chance to hear about kind of the contrasts, the challenges and what some of the outcomes of working on a renewable energy curriculum in Cambodia. Round of applause for Phil, please.
Okay. Hi, I'm Phil. As mentioned, this is my second presentation today, so hopefully none of you are here for the first, because while I have changed the backgrounds, it's the same material. No, not quite. I apologise, but similar. So I want to talk a tiny bit about Cambodia. Since we've got fairly limited time, I'll be quick. So it's tropical, wet and dry season. We've got a largely rural population, which creates a big problem for energy supply. So I'm going to move on from this and I'll talk about that in a second. So energy in Cambodia. Cambodia imports more than 2/3 of its electricity from Vietnam and Thailand. Now, this is a problem Cambodia is well aware of due to its somewhat strained relations with its neighbours at times. So it's not a particularly good energy security situation. Of the energy that's actually generated in Cambodia, the vast majority is diesel and heavy fuel oil, usually in the form of diesel gensets in rural areas. So it's not particularly renewable and it's not particularly sustainable. Electricity. So Mark actually mentioned this morning about working with the small independent operators. So the energy system, or electricity system in Cambodia, is that you pay for a license to supply energy to a certain area. So there's one big area, if you can see this big area down here at around Siem Reap, up north, is mainly supplied by EDC, Electricity du Cambodge. So they're the main provider for a large section of the area. Then there are lots of smaller ones, and the smaller ones vary wildly. That could be anything from a guy with a diesel generator in his back shed to a guy who uses a rice husk biomass generator to generate several megawatts of electricity. It's a real mix. It's often very inefficient. The prices in these areas can range from anything from 25 cents per kilowatt hour in Phnom Penh to well over $1 per kilowatt hour in the rural areas from these rural electricity enterprises. So they've got plans, and their plans are to expand the electricity network, to expand their main grid, more high voltage lines to transmit electricity more effectively. I feel there's not been enough discussion about this with the benefits of a large centralised system and those of a smaller distributed system. Cambodia, as mentioned, diesel and heavy fuel oil is supplying most of its power. It doesn't have large fossil fuel resources. It has to import all of that, so it's not going to improve its energy security situation. It does have large hydro resources in the north and east of the country, but that's the Mekong. And there's some issues with damming the Mekong and damming its large tributaries, which I won't go into because there's several books, papers, international agreements, yada, yada, yada. So, in rural areas, what are you looking at? We're looking at 12.5% of the population of rural areas will actually access to electricity, and those that do are often using a pretty poor connection and paying a pretty high price for it. They're using batteries rather than a grid connection in many cases. They charge a battery up, put that back out in their house, run off that. There's some issues with the way they use of batteries as well. They're not trained in the use of batteries, so usually a lead acid battery will last 2 years and cost them $50, and then they'll have to get a new one, or rather an old one from someone who's taken the supposedly old ones, actually refilled the electrolyte and started using them again. So they're very expensive, inefficient systems at the way they are currently used with most operators. Typical loads, you're looking at lights and fan, they all want a television. They really, really want a television. In many cases, people have put in a solar panel to run the lights and the fan and found the family has switched off the lights and the fan, disconnected them, and tried to run a television. So that's what they want in many cases. They have really good renewable energy resources, really, really good. They've got plenty of solar, it shines a lot, especially in the dry season. In the wet season, obviously not so much, but there is plenty of resource there for solar. They've got, as I mentioned, hydro, not just the big hydro of the Mekong. They've got a couple of ranges of mountains where there's some serious micro hydro possibilities as well. And biomass. It's a largely agricultural society. They grow lots and lots of rice. There's lots of biomass resources there. There's also livestock providing lots of feedstock for things like biodigesters. In particular, solar and biomass are widely available really close to the point of use, so you do not need a big long electricity wire with all the losses going all the way to the village from Phnom Penh. Barriers, and this is why we're working there, or why we're interested in them. The lack of knowledge is the number one barrier for renewable energy. People don't know about it, or they don't trust it. They don't understand it in rural areas. So if they don't know it's an option, they're not going to buy it. If they don't trust it, they're not going to buy it. So we want to try and address that. There's a lack of providers, so there's only a few companies, and those that I talk to are vastly overworked. So there's a lot of people working out there, but they need a lot more. And they need more employees as well, which is good for us. Government regulation and lack of standards are tied together. This is a major issue. Those who've done much with renewable energy know there is a massive problem with trying to sell things and trying to sell out there if someone else has gone in and done a bad job. So that's got to be addressed. And there's difficulties with finance. Right, what we're doing. So we're putting courses in as part of the physics program. The students take 3 courses of renewable energy as part of their program. In the future, we're hoping it will become a dedicated career program for renewable energy. This one is from before, so people will recognise it. The students. So we've got a mix of scholarship and fee-paying students. So many of the scholarship students come from the rural areas. So they're not just educating city kids on how to do this. We're educating people from rural communities who have come to Phnom Penh to study and often go back to those communities, either as teachers or ideally in the future as solar home installers. What we don't get is students from the very poor families. They do not get the access to education to get to university in most cases. Progress to date. 2nd and 3rd year courses are just completed running with over 100 participants in each. It is mandatory for the physics students. We've had 2 students undertake internships last year. One of those is now a solar home installer. One is now doing a master's in Thailand. The first graduates will come out next year and we'll see how many of them get jobs. The 4th year course is completed and ready to be delivered in 2014, and the students for that course, we have 10 of them currently undertaking internships with renewable energy companies, which has been going really well, which I talked about earlier. So if you weren't there, tough. Teaching methods in this environment. So it's historically a rote learning environment, which is a real challenge. Trying to get critical and scientific thinking into the way they're being taught is a really big challenge for us. They get about 1 2-hour slot per week to get taught, so it's not a big chunk of time for teaching, and that slot has to be their lecture, their tutorial, their lab. Okay, so it is not a lot of time that we're getting with these students at the moment. We're trying to bring in that experimental component, and the teachers are completing extra training in the scientific inquiry method and trying to update their teaching skills as well, which has been really good. What we're going to do in the future, we're going to revise, we're going to improve. So there's some courses in place, they now need to be revised. They need to work out how well those are going, what's coming across well, what's not, how can we improve the course and their delivery. We need more experiments and more capacity to do experiments in the school environment, and how to work that. We also want this development of a clear industry pathway. Again, I talked about it before, but we're trying to get that real engagement with industry and try to get a clear pathway for industry to get the employees they really want, and these kids get a career in renewable energy and equip with the skills to make a difference in the sector. So I have a couple of quick pictures of teaching. So this is us trying to get some experimental work in with a simple, small solar panel with someone's big head in the way because he didn't move before taking the photo. We're also doing some work with shading there. You can see a bit of white tape on the end, so we're trying to investigate what the effect is of shading a small part of the panel to try and demonstrate that to the students. But it was really encouraging to see some of the students really get behind this and really begin to understand how a solar panel was working. We also tried to get them cooking. So it was a great little demonstration we had. We had some industry guys along as well, just try and make little solar cookers out of an old esky. Try to concentrate a system with a wok, which was of interesting success. But yes, we had a good time trying to cook these things, and the students, again, got really involved, and it was really good to see them trying to start thinking outside the box and develop ways to improve these systems, which was really encouraging. This is one of the lecturers, Chan Earn, trying to demonstrate to them how they can improve that. Some other students working with a trough cooker, which they actually got to very high temperatures despite being made from an old water bottle. Other ones, again, they've managed to put a lid back on and try to prop it up, which was nice to see. And Tarit, one of the other lecturers, with the wok, and trying to explain to them that we put the thing you want to cook in the middle. And yours truly getting a really nasty case of sunburn. So, I'm going to talk about this very briefly because I'm sure Julian wants to kill me. What we want to do now is try and engage students with the wider world. We want to get more ideas coming into the university. So we're trying to not just engage the local industry, but with universities and educational institutions overseas. Engineers Without Borders is one such institution. Other universities, such as UNSW, I've referenced down the bottom, because they gave me most of the course materials I took over and used to develop the courses there. So hoping to develop closer bonds through combined student projects, through, future work, hopefully helping with the staff, things like that. So that's what we want to do. These are some of the things we've already done with them. So we have done some projects already, and I've seen really good outcomes from that. And it really improves not just their understanding, but their engagement and their motivation for these courses and to do renewable energy. We'll talk about that later. These are the partners, and these are some websites you can visit if you want to learn more about the energy situation in Cambodia, which I glossed over, and some of the people we're working with over there, the industry partners who have become involved in the program and helped us develop a better program and a better pathway for these students. Thanks very much.
Really cool to see, and a very different kind of educational space, and quite a big kind of transition required from transformative in one way from what the kind of baseline was. Again, getting a question for Phil, and don't take his threat seriously about if you didn't know about any particular topic that you've missed your chance, because we're going to put him on the hot seat and you can grill him with any questions that take your fancy. Now I would like to introduce Jeremy Smith from the Australian National University, who's going to give us a bit of a spiel about how humanitarian engineering education can fit in our higher education. So, round of applause for Jeremy, please. So I may or may end up talking about that. We'll see. I've taken a very high-level approach for the topic. So I'm going to start by doing something dangerous. It's the session after lunch, but I want you to start by closing your eyes, which is always a difficult thing to do. And just think about, for those of you who are studying at the moment or just finished or think back to university days, what does your ideal engineering or your ideal degree situation look like at a higher education? What are you doing? Where are you doing it? Who are you doing it with? What are you actually doing? So think about some of those kinds of things. Are you sitting in a lecture theatre like this, listening to someone with a beard, standing out the front, talking to you, and you take some notes? Are you doing things like Tim was doing in his course? Who's involved? Who are you doing them with? Anyone want to share a couple of what their ideal university experience might look like? Yeah? Just graduated, so did you have...
Sorry, mostly it was just graduating and not being there.
So as long as there's an end result, you're happy, yeah?
I was going to say some real-world context. There wasn't a lot of real-world context in what we did.
Yep, so that means it wasn't kind of the things you weren't doing weren't connected to the real world, you didn't get to explore.
Well, you couldn't necessarily see the connection. I wouldn't say they weren't connected, more than the connection wasn't immediately evident.
Yep, anyone else? Yeah?
When you go to sleep, I thought of George Washington Carver, the African-American guy who was just born scientist, and he felt to look at the peanut and discovered quinine and all this sort of stuff. And I've always wanted to look at what's in a banana tree, what's in a mango, and we know all these things can do remarkable things, sanitary pads and special disinfections and all sorts of things, and that's what I want from my engineering, and I'm not an engineer.
So kind of exploring things. What happens if we do this? Let's look at this. How does this work?
The stuff we've got to discover, and it's just there, we just need to look at it.
So discovery, kind of discovering things. So being innovative. How many of you came up with something like this? Sitting in a lecture theatre with a kind of Anglo-Saxon guy with a beard, standing at the front of a lectern. Anyone have that as their vision? Anyone have that as their experience, at least a part of their time? Yeah? I always get concerned because I show this and I look more and more like the guy over there. Every time. So this probably isn't our ideal, but this is a painting of a lecture theatre in 1350, so getting close to 700 years ago. And we could probably take that and map it exactly to most of our university experiences, certainly in engineering. Even to the point of kind of having people, who's kind of had too much at the bar the night before. But these people here are sitting keen, reading, a few peering here, and these ones are kind of chatting about what they're going to do on the weekend or something like this. And worryingly, in the engineering, this is entirely male-dominated, and we still kind of have lots of issues around diversity. So there's a couple of things I want to explore around innovation. It's kind of how can we can do things more innovatively than that. We've been doing the same thing for centuries. Surely we can do something more innovation. So there's one part. There's about innovation in education. How can we have things incorporate ideas into our education to kind of make it better? So what are the kind of innovations? So often when I look at innovation, I talk about Rogers diffusion innovation curve. So you have kind of the early adopters and then the main majority and then the laggards who'll change only because their analogue signal's being turned off and they won't get a digital TV otherwise. But I found something more slightly different that I'm going to try, which is what's known as a hype cycle. So I thought this was more appropriate when we're talking about innovation. So this is a consulting firm. So you have
a new innovation. They have a technology trigger, which is someone kind of discovering it, identifying it. You have the peak of inflated expectations, when it's going to solve all of the world's problems and be the best thing. Then you kind of discover that it's not. You have the trough of disillusionment. Then you realise with a few tweaks you might actually start to get something useful out of it, and eventually it starts to become useful. So I was thinking about innovations we have in education, and I found one of these for education technologies. So not necessarily curriculum approaches, but the actual technologies that are used from 10 years ago. So we can see, one of the things that was actually starting to be used was course management systems, so your Blackboard, your Moodle, whatever your kind of, where you submit your assignments and these sorts of things. Starting to be regular practice 10 years ago, pretty well standard now. If we look back at some earlier ones, so kind of the ones that have gone through their hype and are starting to kind of drop down, e-learning, repositories, e-portfolios, e-environments, obviously very big at that stage. Some of those, probably if we look forward now, you've used those, you might have done an e-portfolio, tracking your competencies over your degree cycle or something like this. But we can see how these innovations come in, they move, they go through various phases. We can take a step forward to now. Anyone kind of got any innovations in their education that they can map onto this, that they've possibly had as a student recently? Some new piece of technology, some new approach? Any current students? You're a current student, Tim? Anything exciting that you've had to go at?
I was just thinking of having the video recorded lectures. It's not that exciting, but...
Yep. Do you think it's kind of been productive, useful, overhyped?
Maybe the productivity section, I'll still be in line.
Yeah. Anyone done a MOOC? Yeah, where do you think MOOCs sit on this cycle, for example? This way? Yeah, okay. I jotted down a few, and some of these are taken from some research. So MOOCs, I probably agree, at the moment are going to solve all the world's education's problems. I think in a year or so we'll suddenly discover there's actually a few issues and we've got to go a bit further. You can see how long some things take. So kind of e-portfolios have just reached this, and this is 10 years down the track. So MOOC, is a massive open online course. So basically, typically a free web-based course that you can enrol in. And there's variations of them, but they typically might have 100,000 people involved in them. And they're basically free, and you do them, and they're online lectures, and you have discussion forums. Often you don't have to pay to get a qualification or a certification out of that. But the theory is that it's opening up education to anyone who's got access to the internet. So most Australian universities probably have a MOOC. They're not quite sure why, but everyone else has one, so we should have one. Gamification, flipped classrooms, adaptive learning, there's all these sorts of things. The only point I'm trying to make here is that in terms of innovations come and go, they go through cycles, we incorporate them, they go forward. We can keep looking at innovation in education for a long, long time. The other point I want to look at is innovation from education. This is where you're being innovative as a student. How can you you're using innovative tools, techniques, methods, your academic wants to try something out, your lecturer wants to try a new method, your guinea pigs, he has a go, doesn't work. How can we kind of have innovation from your education experiences? And Tim was a brilliant example. So you've got a challenge, you're working on that, you're being innovative, you're going to have an outcome that's going to be useful to someone, hopefully. So that's the other way that we can look at innovation from education. And it ties in with how we kind of learn. So these are classic things that you see as well. So, again, coming back to just having someone standing here talking, you retain a small amount of that. By the time you're actually doing something, and the key word there is do, you're learning a lot more from it, you're retaining a lot more, you're going to take it well beyond your education studies. And that's been around for a long time as well. So there's this classic quote from Confucius, effectively saying the same thing. If I do something, I won't understand. So how do we have education approaches that allow you to innovate and do something, so you'll take a lot more away with you, plus hopefully have some useful outcomes? So I've got a couple of examples. A key part of that is around relationships. So you want to do something, how are you going to do that? You need more people involved. So there's an example from what's called the Institute of Making, which is at the University of College London, so UCL in London. And they've got their Institute of Making. It's only been going for about 18 months. This is from their first year report. So really what they do is they're recognising there's lots of people involved with innovation. So we've got a university community, the staff, the students, the academics, all the resources around that. We've got multidisciplinary teams. So if we are looking at being innovative, it's going to take more than just an engineer in isolation or just a business student in isolation. Often you've got ideas flowing backwards and forwards, engineering, design, marketing, sales, communication. So we need to be able to link in those different disciplines as well. And then we've got an external community. So just sitting in our kind of university environment, we might solve a problem that's applicable to a university, but we're not really going to solve a problem to anyone in the real world. So coming back to kind of these questions we had around context as well. So hopefully linking students, linking those universities to that real world gives us some of that context. So they make sure they've got these three pieces in place, and they've got relationships around those. So if a particular problem comes up, a particular challenge comes up, you can bring in people, individuals, skills from those different areas, come together and be innovative. The other element they have for that is a physical space to do it. So it's a physical space to be innovative. Now some of you have probably got some nice workshops and labs in your universities, hopefully. But what you can see from this is a fairly free form. So it's not just a dedicated electronics workshop or not just a dedicated tutorial room. It's basically an open space that has mixed resources. So it's got some prototyping, some tools, it's got some tables, it's got different resources, some bits of gantry, it's going to have some drill sets, these kinds of things. And it's a space where you can just come together. So those different people involved in those relationships, whether they're students, staff, different disciplines, external community members, can just come in, sit down, discuss together, use the tools that are available, use the resources available, and be innovative together. So it doesn't have to be within your 2-hour lab on a Thursday afternoon. You can go through there working with someone. It might be an idea you've got, it might be an idea that someone from an external community's got. But you come together, you've got those relationships, you've got a space with the resources available where you can go and do that. We're trying to look at that at the ANU. We've got one program that we're trying to look at, which I can probably talk about more in the question sessions, around assistive devices and disabled access. Trying to follow that a little bit further as well. So having those external community partners, whether they're individuals or organisations working around a disability space, coming in with their own ideas, their own challenges, something they want to work on, something they might need solved, they might need looked at, something around their workplace, something around their home environment. We can come in, match them up with a group of students, and then basically provide a set of spaces for them to work through that innovation process. So starting from a shared space where you can sit down and discuss, well, what is the actual problem? Is it an idea that someone's got? Is it a problem that you've got that you can't overcome? Let's sit down and work out exactly what it is, but do that in a shared way. That's one separate space. Another space for ideas and innovation. So basically there's a room full of whiteboards where you can sit, discuss, draw ideas around. How about this? Would this work? No, maybe this. But again, it's a shared space where students, staff, external people can come together, share their ideas, share their experience. And then basically you can work through what we consider a fairly typical engineering design process. Do some more design and analysis. You might start putting a bit of rigour into your process. You might start doing some prototyping and modelling, so making use of the tools that are available there. But again, making sure these spaces are accessible to what we consider technical stakeholders, our students, members of the university, but also accessible to the non-technical stakeholders. So if you've got a member of a community who's coming in, making sure that they can still use that space or they can understand that space. So we had Kristen this morning talking about terminology, making sure we don't have kind of too much technical jargon around, making sure that the interfaces into resources are fairly clear, fairly obvious, so anyone can get involved. And then going through and hopefully coming up with a nice new innovative idea that someone can take away and use. And say Tim is going through this process at the moment, so a lovely example we had before. So that's really what I think as educators, particularly in university, you should be looking at. What are the methods, the tools, the resources to allow you to be innovative through your education program. Here's one I pictured from Stanford University in the US. They've got quite a nice forward thinking about what universities might look like in the year 2100. Where basically this is how you would start a degree program. So rather than enrolling an engineering degree or an industrial design degree or a major or something like this, you basically turn up. I think this is the student, this is the staff member, just in case you're not sure. And basically saying, I want to make something that matters. I want to design something that matters. I want to explore use of materials. I want to, find a real world context. And then those universities providing the resources, the curriculum, helping you develop your skills, your competencies around those. But you're really working on something that you think's important. Might be an area that you have. Might be you're working with an external group as well. But kind of breaking down those, how do we move you out of just an engineering lecture theatre or out of an engineering lecture theatre to allow you to actually innovate during your degree program and learn while you're doing that as well as hopefully having some kind of nice outcomes for the people that you might be working with as well. And I think EWB is set up very well for this and does this quite well. It's got those links, it's got skills in universities, it's got students who are interested, who want to make a difference while they're studying as well as in their future careers. It's got the external partners as well. So I think EWB is starting to allow this to happen. The universities need to kind of put some resources around that as well. Opportunities within curriculum, the physical spaces. As you go through those questions you might ask, so who's involved with my education experiences? You know, am I involved with someone outside the university? You know, am I innovating as a result of doing an assignment, as doing a curriculum activity or an extracurricular activity? And how can I do that? So kind of some thoughts to take away, but that's what I wanted to, at that kind of very high level, as academics do.
Jeremy,
Have a quick look at this. Now, I also have a beard and I'm in the front of a group of people. So as soon as we've got the last presentation, we are going to turn around the context. And these are the types of questions that we'll start to work through as a team. So please give them a little bit of thought. Now, I'm also pleased to welcome Will to the stage to hear about the student perspective. What is it like to be doing some of this stuff, a traditional engineering degree, but also be involved in some of a bit more kind of innovative and interesting engineering education programs with a humanitarian slant. So please welcome Will Roxburgh.
Okay, so my name's Will. I spent a bit of time thinking about how I wanted to present today, and I wasn't really sure. I haven't done many presentations, but I heard that a good way to kind of encapsulate what message you want to get out is to express it in a story. So I thought I'd start off with a story to kind of try and bring home what role EWB plays in education, what role I think they play, why they do what they do, where they can potentially go with this, and what innovative activities they're participating in. So I thought I'd tell you a story in two parts. So it's called Eddy's story. So this is part one of Eddy's story. And I'm sure we all know someone who is essentially Eddy. So Eddy completes high school. He's good at maths, he's good at science, doesn't really know what to do, but decides to study engineering. He's an excellent student throughout university, and after 4 years he graduates with first-class honours. After completing his studies, he's lucky enough to get a job working for a multinational chemical company, Chemicals Inc. And after working for this company for a few years, he's a fairly hard worker in the company, and he's given the responsibility of leading a new project in a small community. So there we can see Eddy differentiating himself from the crowd. Eddy is excited about this opportunity and helps construct the chemical plant alongside the community as quickly and as economically as possible. After a few years of operation, some of the equipment in the plant malfunctions, and there is a significant leak. So this causes catastrophic damage to the community, and there are also severe ramifications for Chemicals Inc. And now I put forward this question. What if EWB had been involved? So what would have changed about Eddy's story? What could be different about this story? So this is Eddy's story part 2. So some volunteers come into Eddy's high school and run some cool workshops on humanitarian engineering, and Eddy is inspired to study engineering. So for some reason, like Edward Scissorhands is one of the presenters, but in the first year of Eddy's degree, he participates in the EWB challenge and learns about the importance of economics, but also that in conjunction with consideration of sustainability and community. Eddy becomes involved in his local EWB chapter throughout his degree, reinforcing some of these values. In his final year of university, Eddy decides to do his research project with EWB. And once again, he manages to graduate with first-class honours and still secures that great job with Chemicals Inc. He's given the responsibility of leading a project in a small community. But this time, Eddy remembers the lessons he learned from EWB. He encourages Chemicals Inc. to think not just about the economics, but the responsibility they have to engage the community and think about the social impact of what they're putting in place in this community. He implements a project in which Chemicals Inc. engages the local community, uses appropriate technology, and considers the sustainability of the project. So these are really two counter stories about Eddy and his potential journey through university. And some of you might be wondering, why the story about Eddy? Well, I think Eddy is representative of a huge bunch of students that that don't have any consideration of the social impact of what they might be doing in the workplace. And I think Eddy's story demonstrates the way in which EWB has the power to shift the status quo to an engineering approach that is more sustainable with greater community engagement. So I thought now I would introduce my journey with EWB, some of the programs I've participated in, and the key lessons I've taken from my experience. So I participated in the EWB Challenge in 2011 in my university. More recently, around 12 months ago, I became involved in the South Australian chapter of EWB. Through my participation in the EWB Challenge, I managed to obtain, I'm one of the scholar recipients as a result of the EWB Challenge. Earlier this year I had the opportunity through that scholarship to go on a Dialogues on Development trip to India, which was a phenomenal experience, really eye-opening. And I think it really solidified a lot of the lessons that were introduced through my early involvement in EWB. I also helped start up the University of Adelaide EWB chapter this year, so I think I'm very interested in innovation in education and how we can go about improving the way we engage with students. I think the main lessons I've learned, it's a rather pixelated picture, but the main lessons I've learned through my experience is the importance of community engagement. How crucial it is to think about the social implications and social impact of what you're doing. Whether that's in a development context or a commercial context, I think the lessons are very applicable to any sort of scenario and multidisciplinary. I've also learned, got a lot more insight into appropriate technology. So why we put in place the tools that we're actually putting in place, if the situation is appropriate or not. I saw the topic of this section, so innovation in education, and I got to thinking, how is EWB innovating in education? What is it that they're doing that is innovative? So I asked a few of my friends what they understood by innovation, and they kind of came with this central theme of doing things in new ways. So growing, doing things a new way, doing things a better way, a new method, or creating. And then I applied that to what I thought EWB was doing. So I've created, studying chemical engineering, I've created a process. So we like taking raw materials and making them into valuable products. And we like these things called bulk flow diagrams. And this is essentially what I've done here. So we've got the inputs into the EWB innovative process. So that's high school students, university students and professionals. And then the process. So we've got the high school outreach, the EWB challenge, the research projects, the Dialogues on Development trip conferences like this, and then the outputs. I think the outputs are more holistic engineers and professionals and leaders that consider the social implications of what they're doing. So the way in which they're going about a new approach, what is innovative about their approach? I think it, in part, is the fact that they're problem-based learning modules. The EWB challenge, you're presented with a problem, and you've got to think about not just the best engineering approach, not just the most economically viable, but also consider the social impact and social implications of this, and whether it will be culturally accepted. And I really think EWB is changing the preconceived notions of what engineering is and an engineer's responsibilities. So where can I see growth in education? Obviously EWB is a fairly new organisation, and I think there is room to grow, and there's a number of ways in which I think this can and will come about. There's an opportunity for primary engagement. At the moment there's the high school outreach, so engaging high school students, and I'm aware of a couple of chapters that are developing outreach programs for primary schools, and I think that's incredibly valuable. And it leads to the second point that I've got. So that's more around the pathway of engagement. So at the moment we have high school outreach, then after that there's the first year university program, so the EWB challenge, and then the final year project. But I think there's still some gaps in that continuity of engagement. And I think that having primary engagement and then more engagement between the first and final year of university, whether that's through the university chapter or some other mechanism, would be incredibly valuable. I think we'll also see a lot of organic growth in existing programs. EWB plays a crucial role in education, and they've really changed my education at university, and I think they've done that for a lot of people. They get to engineers early, introduce better engineering practices that produce better companies, and whether you apply the lessons learned to an NGO or apply them to a commercial context, I think they're incredibly important. And also strategies to engage the community. I found my experience with EWB rewarding, challenging, and insightful. I think the lessons that I've learned are incredibly valuable, and I'll take them no matter what direction I go, whether it's finance or engineering. I have no idea at this stage, but I think that the lessons that I have learned from EWB will be valuable in either context. I just thought I'd finish with a recent experience. I was speaking to one of my friends on the South Australian chapter of EWB, and she's really involved in EWB, and I asked her what she felt that she had taken away, what she had learned from her involvement in Engineers Without Borders. And she gave me an example. So she didn't have any involvement in Engineers Without Borders throughout university. And her first project, when she got a job on graduating, she was working on building a pump station in nature reserve in South Australia. And the community used this land as a public reserve. And they were outraged that this pump station was going to be implemented. And she approached this job and she thought, why is the community complaining? It's not their land. They have no right to be outraged. What's the point in this? And through her involvement in EWB, she says that she would have approached that problem in a completely different way. And she wishes that she'd been engaged in EWB throughout university so that she didn't have to learn those lessons through her involvement in EWB after that. So I just thought that was a nice little story that kind of encapsulated some of the things that EWB is achieving in education. So, thank you.
Great. That was really cool. Can we have another round of applause for all of the 4 speakers, please? Now, something that I promised you and that I think Jeremy reinforced is we're not going to be sitting here and talking to you, otherwise you're going to forget 80% of it. So instead of that, we are going to kind of flip classroom this just a little bit. I'd love it if everyone can kind of pair up with someone. So if you're not sitting with someone else, if you can find someone else to kind of pair up. And I'd love to seed 1 or 2 questions while our 4 speakers come up and join me at the front of the stage, and they can participate in this as well. But to answer kind of, just remember back to your educational experience, whether it was school or preferably university, what was kind of your frustration at the time? What is it the thing that you wish you could have learnt about but didn't? And do feel free to kind of think about what some of those kind of innovations could play to have rectified that situation. That's kind of one question for you to have a quick discussion as a group. The other one is I want to really challenge these guys. So think of what do you think the hardest question is you could ask these guys to make them ponder what they do. I would like to see some sweat. I wouldn't mind if one of the 4 members left in like some tears. Let's really put them on the spot because it is a pretty bright group that has had some exposure to this stuff before. So let's dive a little bit deeper and explore this topic at depth. But please take a couple of minutes, and you guys can do the same, to kind of answer that question. Something you would love to see rectified, and a kind of tough question to chuck at these guys. And go.
So we were just talking about what we liked at university and what we didn't like as part of education. One of those things is to include more real-world examples, which was kind of mentioned a bit. But in terms of academics seem to differentiate their lecturing and research duties or other interests, and that it was better if they could be combined in a way that if an academic gets involved in a real life project, that is then included in next semester's slides, the semester's tutoring, rather than what we've found is that the slides that an academic uses can be 10 years old and, the same as ever. So it's not even an innovation, it's just, just more academics should be innovating in that way, yeah.
Anyone want to chime back in? Jeremy, how old are your slides, my friend? I don't have slides, I cancel all my lectures. Is that because you stopped teaching, or what did you do in response? Look, there's lots of... I think it's a placebo microphone.
Should switch on, that's how we get it.
You have to turn it
Yeah,
on.
that's how we get the audio.
That's a second. No.
Look, there's lots of ways to respond to that, or I could respond. And unfortunately, I keep thinking I'm putting my university hat on. I agree with you, and these guys were raising some similar kind of questions. Purely in terms of putting together slides or whatever, it's basically a time factor as much as anything else. Putting together good slides takes time. Writing up a good case study takes time. And unfortunately, I don't think university academics are given the time to do that. Basically, the time they're given for teaching is day one of semester to the day end of semester, and you have to try and prepare everything in there. That answers a cop-out from my point of view. I think the other aspect of this is, and if I was going to put it on a hype cycle, research-led education. Anyone heard of research-led education? So this is, you have academics and researchers and their research leads their teaching, which is what you're trying to get done. And there's different ways of looking at that. So one way is what you're talking about is an academic does some nice research and they write it up as a case study and they incorporate it. That's a nice simple way of doing it. It can still take time. Should certainly be given the opportunity to do that. That's what academics should be doing. It's contemporary, it's the current trend. Another way of looking at research-led education is students being involved in the research process. So not just having an academic doing their research, then write it up as case study. How the members of the class, the students, being involved in that research process and being involved in the process of discovery and actually being engaged in that, not just seeing the end result of it. And I think that's probably, how can we get that more interesting bit to get done? So it's still shifting it from, you're still learning from what someone else has done to you're doing the actual doing of it. So you're involved in that research process. We get to do that for our final year projects or whatever, but often the first 3 years is you're not doing that. So how can we get students involved in that kind of research and discovery process is probably what I think we'd be trying to do, which takes time and resources, but if you've got a vision to do it and you can see the outcomes, then you can make these things happen.
That's great. What was your main point at university? What was the bit that you got frustrated with at university and thought there was room for innovation?
I work in curriculum design, so my frustration is sometimes when we start off with what Engineers Australia wants. And so Engineers Australia has a very conventional approach to what they expect. So rather than, they expect a foundation of knowledge and then a capstone project at the end. And I think what you're alluding to here is a confrontation, what I'm not calling an incremental approach, but a confronting approach, where you say, I'm going to confront you with the situation quite early on in the program, rather than after graduation. And my wariness is, well, I'm very approval seeking in my role. What will people often think of it? What is the, will I be liked if I dare something so radical? Yeah, the other conversation we had was, what was the P? What's the problem? What's the possibility? What's the project? So one was when, and my understanding is that we do use EWB in first year. But we're challenged by wariness. We like the rhetoric of PBL, but we prefer to have it in fourth year. Whereas this idea of stuff in first year, large classes, we're daunted by the logistics of it, the large numbers of students, and we lose control. You might have how do you get an octopus in a glass? How do you get all the students to do stuff? And how do is it still marketable? Is it still comparable? It is labor intensive. It kids, and I think I do think that we also work with teachers who themselves decide that their teaching style is based on how they themselves were taught, and the distortion we have with academics is that they were very good students. They were very obedient listeners as well.
They need the support.
So their teaching approach is often emulated not on good teaching practice, but on how they themselves were taught, which is often, it's a bit like what I'm doing right now. I'm just enjoying the tone of my own voice and the...
Well, we're going to cut it off there and that's the right thing. Now, Tim, I don't know if you are a good student or not, but...
Juliana, if I might, our question was, if we were to reverse university courses and allow you to pick your final year project in first year, and then design the teaching around what you were interested in, would that engage you more? What would that mean as a student? Would it engage you more in what you were learning? And then I think we touched on what it means for the academics.
So that's what I'll throw to you then, Tim. Like, rather than this is a baseline level of kind of professional skills to have, but here's a significant problem worth solving, and you're having a crack at doing that. How do you think you would have reacted, or how could you see that working if this is what you got not at the end of a significant engineering degree, but in year number 1 or year number 2?
I think it could have been really good in a way, just to have something to sort of focus on, but as well, just coming out of year 12, I know myself anyway, I didn't really feel like I knew anything at all, and a lot of people didn't have much direction as well. I still don't really know what I want to do with my career. So it could have been quite difficult as well, just to choose something. A lot of my interests have formed over the few years I've been studying. I didn't really know what I was interested in at the start, and so it might have been difficult in that way, just without much skills. I remember we did the EWB challenge in the first year, which was a really good challenge, and a lot of people struggled because we just started year 12 and they threw us sort of real world problems. We had to design like a water supply system, an energy system, and housing for a remote community, and it was really, really tough to actually think about a real world problem instead of just solving simple little physics problems in the classroom and things. But I think doing it earlier could definitely be beneficial. At least to think about it from the beginning could be really good, yeah.
I think it's a really interesting one. I think there's one of the bigger gaps between what engineering is and what engineering education is that once you get a job, you're never asked to just put a number in a box with the correct units, but that's a significant part of the assignments that you get from day 1 to day 4. So I think that's a kind of neat example of where using that.
Something briefly.
Please do. You are the expert, my friend.
No. I think that it is tough to select. I think that students are overwhelmed enough, high school students are overwhelmed enough at the prospect of choosing what degree they're going to do, let alone choosing what they're going to focus on within that degree, which is, I guess, why you look at universities like Melbourne where they are doing more broad undergraduate and then focusing more afterwards. Having such a specific focus in your first year is quite dangerous. I think that the EWB Challenge is an excellent opportunity that can be, that allows for some breadth in terms of where you want to put your focus towards, provide some real world context. And I think there's also the opportunity for companies. So in my finance degree, I think I've learned more in competitions than I have in any of my subjects. So companies putting forward competitions for recruitment. So companies running investment banking competition, and then you have to like work out the problem, work out the solution. I think there's opportunity to have those sorts of things in engineering, and they're not currently there. So that would be another way that wouldn't mess with the EA framework of what fits in for their course to be accredited.
I think it's a really neat idea as well, the concept of that informal education that sits adjacent to everything that happens in a classroom. I'm sure people have been involved in things like Formula SAE, like being an Engineers Without Borders volunteer, which isn't part of the curriculum at every credit point, but is, I think, a big part of the learning process, and definitely worth capturing. Now I'd like to kind of shift it towards what you guys are thinking. So if you guys have something specifically that you'd love to chuck into the mix, or we'll get started on these tough questions for Phil, Will,
Jeremy and Tim, that's what I would love to get to. So who's got something that's on the tip of their tongue that they would love to chuck in? Kim, fill us up.
One of the topics came out of ours was the idea of broader, more generalist education and the multidisciplinary. So maybe for Jeremy, with the Institute of Making, or for any of you, have you ever heard of any universities that are doing truly multidisciplinary work, like not just the civil engineer and mechanical engineer, but actually, like the engineering department and the health sciences department and really multidisciplinary?
So at ANU we have what's known as the VC's courses, the Vice Chancellor's courses. I think they're called the VC's courses because he sat down with someone and had a bottle of wine. At the end of the night they came up with this concept. And it's basically what you're doing. So at ANU we have 8 discipline colleges. So we have engineering, computer science, we have kind of law and physical sciences, and there's a few other ones. So the VC courses, there's one in first year, one in second year, one in third year. And they have approximately 80 students, or a maximum of 80 students per course, 10 from each college. So in that case you're basically having 10 from each of those disciplines come together. And I can't remember what the first year course is called, but the second year is called something like Unravelling Complexity. So you get thrown a complex problem in your multidisciplinary team and you look at it from different points of view. And then the third one is about leadership in an uncertain world. So then it's kind of taking that a little step forward. So that's one example I know of where that's done. What I've heard anecdotally from that as well is the engineers actually do quite well in those areas. There's always a very good education outcome from learning a terminology and the thought process of the different disciplines. So you get given a problem and each discipline does have different ways of approaching that, even if it's just the terminology they use. And what I've heard anecdotally is that you might talk around and everyone has different approaches and these sorts of things, but as a deadline draws up, the engineers just go, right, okay, well, let's make sure we can have a solution and just work towards the solution. Which may be a pro and con, but engineers do have this, we drill it in that there's a problem, come up with a solution for it. Sometimes maybe we shouldn't do that. So that's what I know of. Have you guys you're doing double degrees and any other?
Yeah, I'm also doing a Diploma of Languages, which I found really beneficial for me. Just having different people around. My mechanical engineering degree is about 95% guys, and the French courses are 95% girls. And most of them are in arts and international studies, and it's been, for me anyway, I've sort of developed a real passion for it, and I'm keeping it going as long as I can. There's not, in my actual engineering degree, I don't think there's been really any mixing with other students otherwise. We do get electives, but unfortunately we get, in RMIT anyway, we only get about 2 or 3 electives. And often you're limited, you want to choose something that's in engineering to make it look better for your transcript, or you want to choose something easy and get a good grade for your GPA. But it could be really useful if there were more electives. I know a lot of people don't like it when there are as well. They like the Melbourne model, so I guess it depends on the person a lot.
There's a lot of content in Australian engineering degrees. I think our American colleagues have the ability to do a French subject within an engineering degree. That's just really not available to our students in Australia. So I think we are kind of very much, there are some different models like the Northern model out there which are looking at it a bit differently, but there's a lot of content and very little space, I guess, to kind of play, to explore, to add a bit of ancient history to your area of expertise. Please.
One of the things, having been at university in Europe, very recently in university in the UK, pretty much, most of my school friends in Italy had the opportunity through European Union funded scholarship to go to a university overseas, or maybe that's something that in an Australian context with Asia Pacific focus, universities could do more of, embrace, like I guess you've done at Phnom Penh, just embrace the area and spend time there and learn the language and mix it up a bit. Just a thought.
Well, I think it would, and I think it's something we need to look at. I guess going through my own degree and people I knew at university, I did do exchanges, but it was almost always to Europe. There's that strong, desire to go overseas to Europe, something like that. And I think there's probably a couple of factors. One is, I guess, comfort and convenience to some extent. It's a bit more a challenge to put yourself in a different environment, if that makes sense. Europe's seen as a more similar environment. And the other one is probably slightly to do with the prestige of the universities as well. You could at the university in Australia recognise that the courses you're doing in a developing country, for instance, have the same value as the courses they teach, and that is a little bit against, most universities' pride. They like to think that they're even a pretty quality education, and there's a reason people want to come to their university. So I think there's huge benefits to it, and I really think, I guess one of the things we're trying to do with Phnom Penh is trying to get more student engagement. So it's not the same level as someone going over there and experiencing life for an extended period of time, but trying to get that communication between degrees and communication between different students in different places to get those new experiences with people in our region.
Jeremy just fun as well, but one quick thing I'll note, we've done some research into this, and engineering students are some of, if not the least likely students in Australian universities to have an overseas experience. International development students, international studies students are unsurprisingly the most common, but very much at the bottom of the scale, and it's perhaps due to things about getting things recognised, very full degrees where you've got no spaces for electives to just get credits, but you've got every subject's got to count, so it's a real challenge.
Just a bit on, so I did an exchange to Singapore for 6 months. So even though it's not the development scene, there's significant government incentives for people to go to Southeast Asia. I'm wondering if you're more asking about the possibility of becoming involved in are you talking about student exchanges specifically, or more work experience in those? I don't know. For me, Singapore was, apparently it's one of the best universities for engineering, but I didn't see any real differences in their education model to what I see in Australia. It was very much rote learning.
The thing about prestige is interesting. The Indian IITs are incredible institutions, but I don't think they've got the same reputation here in Australia as they perhaps do elsewhere. So I think that maybe we're unfamiliar about what our neighbours and our partner countries do have and could contribute would be something worth exploring. Any other kind of thoughts or questions into the next for these guys? Yeah.
I had a question for Will about Eddy. So Engineers Without Borders is providing a whole different way for engineers to think, and I think they're a bit ahead of the time. And I see a problem in that a lot of engineers won't be able to go into traditional modes of humanitarian engineering, and they're going to have to work for a company like Chemicals Inc. But Chemicals Inc. is still going to build the same factory, and Chemicals Inc. might still have that chemical spill, and Eddy's still going to be in that role. And I'm just really interested in what EWB, how EWB thinks engineers should respond in that situation, but also how you might respond to someone who has had involvement with EWB.
Sure. So I have had very in-depth discussions with people about I'm quite interested in working in oil and gas, and a lot of people question my idea of potentially going into that industry. And I often use the justification, however you think about it. I say that would you rather me with some understanding of social impact and community engagement go into that job, or would you rather someone with no understanding of that? And I think that it is a shift in the approach to engineering. It's not going to happen overnight. These huge companies are going to continue building those factories, and until there's enough economic penalties for them, they are not going to change. I think that if you can provide something that's economically viable and socially good, with an increasing importance placed on companies' CSR policies and on their engagement with communities, I think that they will lap it up. And it's a matter of getting enough people into positions of authority or positions of leadership in those companies so that there can be more systemic change in corporations, I think.
There's a second question to that. Do you think there's enough people in EWB who are willing to, I guess, suffer the backlash from being someone who's interested in EWB and saying, I still want to work in oil and gas? Is there enough people in the EWB community willing to sort of take on those bigger corporations and bring them down from the inside? I totally stand for people working in oil and gas, but I know there's a lot of other EWB people who might challenge people who take that career path on.
Well, I could maybe argue with them to say that they're taking the easy route, and that if you actually want to create changes, these are the multi-billion-dollar companies. I mean, I think that it's a reasonable argument, and I think that you can make a fairly strong argument for the case of working for these companies. And I don't know, it'll be interesting to see what happens. I think that if we can run the EWB challenge in programs like that in enough university settings, there's at least people who have an awareness of community engagement and appropriate technology. Whether or not they engage in it later on in their degree, ideally they would, but if not, at least they have some basic understanding and some, I guess, fundamental knowledge about it.
I might respond to that as well. And so that I think the engineering sector's done this once, and that's with sustainability. There's no major engineering company in Australia that doesn't have a sustainability policy. It means they haven't at least thought about it. They don't have something that their board hasn't at least looked over and approved. It isn't embedded into every major project they do. I think that there is time for kind of a revolution to do the same process that will happen probably since the 1970s to now. We're kind of looking at the environmental stewardship of what we do to, what are the broader community, social, cultural ramifications of the work we do. So I think that EWB really should take a two-pronged approach. Let's support every engineer to be a little bit better, and let's also make some champions that are actually going to really drive through the big change in big companies. I'm going to draw from Jeremy's percent again, which is, you take away a bit that you've been involved with, but you take away 90% of what you do. So to kind of wrap up in the last 10 minutes of this session, I want you guys to do, and that is back in the groups that you were, come up with, now we are living in the 2014, the Twitter era. Those that aren't on Twitter, you've only got 160 characters to get your message out into the world. So I'd love for you guys to develop your own engineering education innovation, a pitch that can be said in 160 characters. That's one SMS length of time to come up with what you think could be something that makes a positive impact on engineering education. You've got 5 minutes to do it, then you get a spokesperson to come up and just give your tweet.
Do you use hashtags? So it's a pitch for a new engineering program.
An innovation in engineering education. You guys have to, actually you guys can do one each, please. You have to prepare a presentation. I'm not on Twitter.
Why are you looking at me?
I know this group, I know this group though.
My name is Rich, and basically we people are reintroducing a fairer form of apprenticeships as a way to address the gap between practicality and the practical and the theoretical. So
you're done there.
In a tweet, it's reintroduce fair apprenticeships.
Wonderful, round of applause. Well done, guys. That's cool. Let's absolutely touch on something these guys said. Let's bring the real world and make it part of education. I love it. Folks at the back.
We didn't really come up with one. I got one.
You have to do better than that. Go on.
Increase multidisciplinary education, hashtag UniLife, hashtag more nurses, hashtag beer.
Done. Round of applause. Well done, guys. It sounds both fun and multi-skilled. Camilla, Tracy, your team.
It needs to be tweaked a little bit.
Yeah.
Something along the lines of do unto others as they would like to be treated, or as they would like to be. It's a play on that golden rule.
Yeah.
Do unto others as you want them to do to you. Do unto others as they would like to be done to you.
I like it. Hashtag compassion. Very cool.
Yeah, empathy. We're talking about experiences of empathy.
Wonderful. Round of applause for empathy. you folks? Let's hear your idea.
Involve us, engage us.
Involve us, engage us. That's good.
Involve us to engage us.
Brilliant. That is awesome.
I'm not very practiced at quiz and run stories.
Wonderful. Well done, guys. I like it a lot.
So we had subjective creative education through doing for life. Hashtag Engineers Australia, EWB CPD. So the idea of engaging professionals after, through past university.
All right, lifelong learning. Well done. Round of applause. Next to you.
People with diverse skills and backgrounds working together to solve hashtag real world problems.
Nice. Round of applause. Well done.
So answer would be something like the EWB has opportunity to inject more projects in second and third year engineering, which is very good.
Brilliant. The future. Well done. Down the front.
Equations in moderation. No learning is wrong learning. Flip our course, 4th in first year. Hashtag, it's a long hashtag. Courses for students by students and professionals. Hashtag YEA.
Nice. Well done. Feels like an abuse of the hashtag system.
Really want to thank these guys here. I want to let them leave for you with their parting words. Jeremy.
I've got engineering classroom representative of society.
Would that be amazing to see, Will?
The way forward is private investment. Companies can provide real-world problems for students to solve. Hashtag recruitment, hashtag multidiscipline, hashtag learning, hashtag fun.
Thank you, hashtag fun, please.
I was the same first thing I had actually. I was going to say sort of industry-based learning, hashtag student consultants.
Oh, dig it.
I'm going to go with more project work, more passionate staff, and more interdisciplinary work.
Great. My one is more of these amazing ideas in the education system. That's what I would love to see. Now please join me in thanking our team. We've got 3 gifts because as Phil said, he's already spoken before. So not that we don't like him, but he's already been gifted today. So we're going to give, why do I always get the biggest one?
Because you have to travel the furthest.
I know.
Last time we gave him like a chandelier, so take that. Please, lots of clapping while I give these gifts to our Afternoon tea time, you guys have earned it. Well done.